on example 2, we want to graph this function and then describe the key characteristics. Notice what happens here. It's been translated to the left 3 and down 4. So I'm going to go to the left 3, 1, 2, 3, and down 4, 1, 2, 3, 4. Well, need the point there. And then it's symmetric around that point. So we want to describe the key characteristics again. So my domain is all real numbers. My A didn't look very nice there. That's why I paused there. All real numbers. My range is going to be all real numbers. My x-intercept, remember that's when y is 0. So I'm going to say 0 equals the cubed root of x plus 3 minus 4. So then I'll add 4 to both sides. So 4 equals the cube root of x plus 3. Cube both sides, so 64 equals x plus 3. So x is 61. So your x-intercept at 61. Yeah, we can't see it on this graph, can we? And then your y-intercept is when x is 0. This one we can maybe do mentally. Replace 0 with x. 0 plus 3 is 3. Take the cube root of 3 and then subtract 4. So my y-intercept is the cube root of 3 minus 4. It's a decimal. Okay, let's do our end behavior. As x approaches infinity, f of x approaches infinity. As x approaches negative infinity, f of x approaches negative infinity. And it's symmetric around negative 3, negative 4, and that's your point of inflection. Okay, let's do the next one. So this time, we're going to start, notice retranslation, we're going to start at 1 and 3, but then we're going to have a dilation of negative 2. So I think we might make a table for this one to get us an idea. So I'm going to go x and y. So I know I'm going to have it symmetric around 1 and then 3. Now I want to do the cube root. Well, I can do the cube root of 1. So I'm going to say 0 and I'll go 2. So 2 is going to be the cube root, or 2 minus 1 is 1. The cube root of 1 is 1 times negative 2 is negative 2 plus 3 is 4. Let's put in 0. 0 minus 1 is negative 1. The negative 1, the cube root of negative 1 is negative 1. Times negative 2 is 2, plus 3 is 5. I think that should be enough points for us to get an idea of where we're going here. So I'm going to do to the right 1 and up 3. And then when I go over 2, I'm going to be up 4. So my graph looks like this. So now let's describe the key features. And once again, my domain and range, they're the same. It doesn't matter about the transformation. So my domain is all real numbers. And I just noticed something. If I do 2, that's negative 2 plus 3, that's 1. So I got my graph backwards here. Let's try that again. So over 1 and up 3. Yeah, my pen die here. Sorry about that. And then when I go over 2, I'm going to be up 1. When we be at 0, I'm going to be up here at 5. And there's your cube root. Okay, so my domain is all real numbers. My range is all real numbers. Then let's look at our x-intercept. My x-intercept is when y is 0. So I'll put a 0 in here for y. So I'll subtract 3 from both sides, so I get negative 3. I'll divide by negative 2, so I get 3 over 2. And then what I'm going to do is I'll take the cube, I'll cube that. So I'll get 3 cubed over 2 cubed. And then I'll add 1 to that. I don't know why I could put a parenthesis there, but let's get rid of that. So I have 27 over 8 plus 1. Well, 27 plus 8 would be 35 over 8. So my x-intercept is at 35 over 8 and 0. My y-intercept is 5. I already did that in my table. And then as x approaches positive infinity, f of x approaches negative infinity. As x approaches negative infinity, f of x approaches positive infinity. It's symmetric around the point 1, 3. And that's the point of inflection also.